My project's on anaerobic fermentation of food waste. To start with a little context, the UN estimated that in 2019 the world produced somewhere along lines of 931 million tonnes of food waste around the globe. And the best thing you can do with food waste, of course, is reduce it. And as such, the Sustainable Development Goals want to reduce from a 2007 baseline by 50%. This means that a conservative estimate by 2030, if everybody meets their targets, we're still going to be looking at 500 million tonnes of food wasted every year. And for this, we need to find something responsible to do with it, because there'll always be, as we can see just in the sandwiches yesterday, there's always going to be a portion of the fruit rinds left, the heads of the watermelon. There's always going to be a portion that we need to manage responsibly that can't be eaten. And one option that people are looking into is anaerobic fermentation. This is also known as bokashi. It's a lactic acid fermentation process, and the way this works is that food waste, usually as it's generated, is layered with a bran that looks like this, or a spray that's inoculated with a microbial mix of lactic acid bacteria and a few other fungi. And this starts to break down the food in an anaerobic process in a sealed container. This produces lactic acid, which drops the pH of the mix down to about 4.2. This creates a hostile environment for other bacteria that would begin the sort of rotting process that would otherwise produce CO2 or methane. So theoretically, it's a low carbon fermentation process, and this fermented product, which comes out as a solid and a liquid, can then be buried in the soil, where it continues to break down and in theory produces a slow release fertilizing amendment. And our key questions is it all it's cracked up to be, and could this be useful at the mid to large scale? It's got a fairly dedicated sort of home garden scale following at the moment, is commercially available, but whether this would scale up successfully. To answer this, we want to answer three key questions, which is, can it be a practical, successful waste management technique? For this, we need to ask both physical questions, such as on the fermentation, what are the tolerances, what are the minimum requirements, what are the practical needs that you would need at this sort of scale. But we also need to ask human questions, things like, will people interact with this system? How will food waste behaviours influence the variation of what's going in, and so the variation of what's coming out? And also legislative barriers. We need to identify and cost effectiveness in order to see whether this would be practical as a waste management method. Following on, we need to know what the actual product produced. Can this be a high value soil amendment? Can this be useful to people and end users potentially in the agricultural sector? And for this, we need to know the key nutrient qualities of the solid and the liquid. How is this dividing into these two products? How does it interact with the soil once it's in there? And finally, we need to know, the key question is, can this store carbon in soils? Is this useful for that end? And for this, we need to know, truly is the fermentation a low carbon process, as it's reputed to be? And what actually happens when it's put in the thing? Does it respire very quickly, a lot of the CO2 straight back out again? Or can the CO2 be used microbially for growth and so stored in the soil for a long time? And putting all these together, we'll be able to find out whether this has a role in the society in the future for low carbon circular economy, and essentially answer, can we do it and should we do it? Thank you.
Thanks, Sam. Before we go to other questions, can you clarify to me, so the bokashi method, okay, how long has that been known for? And it's used on a small scale at the moment, did you say?
At the moment, yeah.
By commercial companies, or
commercially, you can buy the bran and sort of the specific bins that have a little drainage tap. And it's done sort of the same kind of level as maybe home composting or worm composting at home. It's been around, sort of slightly sold since like the 80s, but it's really kind of come off in the last 10, 15 years. And people that do it at home are fairly dedicated believers.
So I could buy myself a bokashi bin, could
Absolutely,
I?
yeah.
Okay.
And it's getting more and more attention. Whether this would scale up is a question, though, that hasn't really been answered yet.
Okay, fascinating, thank you. Jess?
Thank you. I was wondering if you could elaborate a little bit more on your methods and how you're going to test these things.
Well, a lot of the physical questions about what's going on in the fermentation, what the products are, this is going to be small lab tests, as you can see on the picture on the right. making sort of food wastes initially out of potato and cabbage at the moment, just to try and get an idea of what the processes going on are. Hopefully we'll scale up this to real food waste from on-site, and then build up to field trials to work out the action in the soil, especially how this might be best applied, what are the best methods in order to maximise carbon storage. And we also want to do collection trials. There's a potential at Reading Berkshire Hospital there. They've got a wellness garden for their staff, and they're quite keen to put a bokashi collecting bin, and there's a few other community groups in London that are quite keen to test out collection in a residential scale, collect it at a slightly larger scale to make it. So we've got a few different ways to look into the whole sort of food chain, essentially, of this waste management technique.
Lovely, thank you. Can I have a quick follow-up? Very quickly,
yeah.
Just wondering, is there nutrient difference in the liquid and the solid forms?
At the moment, that's a big question, because at the moment people tend to chuck the liquid form. Potentially you can reportedly dilute it and use it as a fertiliser itself. But quite often at larger scales people just pour it away. So what we'd like to know is how much are people wasting of their waste.
Okay, lovely, thank you.
I think Katie and then Dave. Yeah.
Thank you. I just wondered what, you've slightly touched upon this in your previous to last answer, but what do you consider mid to large scale?
I was thinking personally at the sort of university scale, organisational scale. Larger scale I'd consider perhaps council collections, things like that. And it may well be that it is useful at one scale and doesn't quite add up to the next scale. So kind of look at a range of scales to see how this might scale up.
Thank you.
Hi, I guess mine's a similar question to Katie's. What actually happens at the moment in terms of all the food waste that's collected by the council, for instance? So
Absolutely.
What happens to that, and then why is this a better option?
Yeah, good question. At the moment, if it just goes into the general waste, it ends up in landfill, and that is a big problem because it's producing methane, and essentially all those nutrients that were in the food is also being wasted. In a responsible collection, it'll either go to compost, great big compost plant, which is quite an intensive operation. They've got to keep that heat up, they've got to keep turning it. It's quite a lot of input, and also a lot of carbon dioxide is lost, which essentially, it would be ideal if that could be kept and put back in the soil rather than let off as carbon dioxide. Or the alternative that's been considered sort of the green option at the moment is anaerobic digestion for biogas, which a lot of the council services are going towards. And this is, it's a bit debated over how green this actually is. There's also a lot of capital input. The smallest you can look at is about £250,000, up to millions and millions, whereas this is sort of a fairly low tech, comparatively much lower input capital needs. And anaerobic digestion, they can get the biogas off, which is good, but the product at the end, the digested product, is considered fairly low quality, and isn't accepted on all farms. And there's going to be, I think the Welsh Government is putting in, for instance, controls because of ammonia volatilisation. Just the nature of the product means it's fairly sort of volatile and not very stable, whereas this is a bit more stable, a bit less kind of capital intensive, so it might sort of slot in somewhere at the mid-level especially. Yeah.
Right, thanks.
Anything else? I think it's time to have a break. Thank you very much, Sam.